Section 6.3, example 1, A. We need to find cosine of 135 degrees. So how do we do that? To find cosine of 135 degrees, we need to find its reference angle. And later on next slide, we're going to explain in details what that means. But basically what we need to do, we need to draw that angle on a coordinate plane. Let's see here, coordinate plane, y and x axis. There we go. And then if we can imagine that 135 degree angles is 90 degrees, which is this, and then we are left with 45 degrees. So 45, half of 90, our angle would be like that. So this is 135 degrees. Now reference angle is an acute angle, so we actually need to drop a side down toward the x-axis to make a right angle over here, and this reference angle is 45 degree angle, and it is in the second quadrant. Now this is our theta. We can imagine it's just its cosine of 45 degrees. This length, if you recall, it's just x, but since it's on negative side, it is negative. And then this is y side, and it's positive because it's positive y. So cosine of this angle is, and again, this is r, cosine is the adjacent over the hypotenuse. So it's negative x over r. So we know it's going to be negative. Now, what the values do we add here? So we use special right triangles. And if you recall that if this is 45, 45, 90 triangle, we define this as side of 1 unit. This is 1 unit. And then if we find the hypotenuse, or you recall what the hypotenuse of 45, 45 degree triangle is, it is square root of 2. So the value of cosine of 135 degrees is negative adjacent, which is negative 1 over square root of 2. The only thing is that, and I put negative here and here, that was just supposed to be one of the negatives. So let me just erase one of them. It doesn't matter which one it is. So what we have now is the denominator has a radical in it, and we can't have it. So if we remember, we have to multiply top and bottom by square root of 2. And that gives us negative square root of 2 over 2. And that's the answer. Whoopsie. Now, what about tangent of 360 degrees? Tangent of 390 degrees. So what is that? So first of all, we already have a full circle of 360, right? So there's only here. Okay, so we can imagine that we went around the circle once and then 30 degrees more to get us so if I draw it like that, this is the 30 degree, that's the reference angle we have, because again we always drop down the side toward the x-axis and we're making the right angle with it. So this is now 30 degrees. Height is y, it's positive. This is x, it's also positive, right? So we know it's going to be a positive value. Tangent of 390 degrees will be positive value. This is 30, 60, 90 special right triangle. And if we recall, this is side of 1 unit, then the hypotenuse is twice as long, so it's 2, and the adjacent, or that second long side across the 60 degree is square root of 3. This is again special right triangles, right? So we need to remember those two. They're very important, and this is something that's going to be repeating many times. So now, what is a tangent of 30 degrees, which is the reference angle for 390? It is opposite over adjacent. So first of all, again, it's x over x length over the y length. Oh, I'm sorry, the other way around. Y length 1 over the x length. And like before, we have a square root in the denominator. We can't have it, so we need to multiply top and bottom by square root of 3. Which gives us square root of 3 over 3. Again, I'm writing with a mouse, so it's really hard to do. So apologize for my writing. There you go, square root of 3 over 3. That explains the reference angle together. Let Q be an angle in. Let Q be with is the angle formed by the terminal side, is the side, basically the blue side that you can see on the screen, of theta, and the x-axis. So you can see that if this is the angle, just this one, then theta is the same as theta bar. If your angle is obtuse, then you're finding your reference angle. If it's in the second quadrant, you drop down the side toward the x-axis and make a right angle to it, and this is your reference angle. If your angle is even larger and it goes into the third quadrant, then you draw a side from that terminal side and make again a right angle with the x-axis, and this is your reference angle. If your angle is even larger and goes to fourth quadrant, you again make the side, you drop the side toward the x-axis, always toward the x-axis to make a right angle with it. And this one is the measure of this angle is your reference angle for that whole angle theta. So here we have example 2, and we have a theta. Find a reference angle for theta equal 5 pi over 3. So here we're just finding the reference angle. So how do we do that? First of all, you can, if you remember, we have pi is a half circle, right? That's 180 degrees. You could think of it this way, just to put it in perspective. Then 2 pi, it's a full circle. So it's 360 degrees. How do we draw 5 pi over 3? So it's almost a full circle. It's not entirely. You can see that the only thing that's missing to complete it to a full circle, 2 pi, it will be 6 pi over 3. So only pi over 3 is missing. So how do you usually find when you have angle in terms of pi or in radians? So in this case, you know it's almost 2 pi, but not exactly. So you subtract 2 pi minus 5 pi over 3. Right? If you convert this, this would be just 6 pi over 3. So it's just pi over 3 is your reference angle, because that's what completes it. And how do we know that? Because again, if you draw it, it's going to go all the way around, and it's almost a full circle, so it's going to stop somewhere here where you would draw your terminal side, and since it's in fourth quadrant, you have to drop the side toward the x-axis, so that with the right angle here. And your reference angle is then this one, what completes it to the full circle, and it's pi over 3. What about theta equals 270 degrees? How do we find that reference angle for such large angle? first of all, you need to just figure out how many full circles there are, and we can see that there are two full circles. Two full circles are 720 degrees. So what's left? If we subtract 870 degrees minus two full circles, right, which is 720, we're left with 150 degrees. Whoopsie, that's a large zero. Okay, so now when I draw that, again, how will we draw this angle? Let me just show you. So again, we will go around twice. 1, 2, right? That's two full circles, and then 150. So 90 is here, and then we're still left with 60 degrees. So it will be 60, right? And that will be our angle of 870 degrees. Since it's almost at that 180 degrees over here, we know we have to drop it down this way because it needs to make right angle with an x-axis. So this, whatever is left, what would complete it 280 degrees, is our reference angle. And since this from here to here is 150, this is just 30 degrees. So the reference angle is 30 degrees. There we go. Oh, doesn't want to write. Okay, there we go. 30 degrees is our answer for that.